Light dimmer using Diac Triac. As we can see from the circuit, the intensity of lamp source can be varied over a wide range by using a triac. As we know, a triac is a bidirectional device which requires a triggering pulse at its gate to perform both half cycles. A diac is used in the circuit for triggering purpose. The diac triggers the triac. Working. In this circuit, a lamp acts as load, a potentiometer is used for varying the firing angle of the triac, and a fixed resistor R at the potentiometer is at a zero resistance value. The resistance value by the potentiometer decides the charging time constant which is required by the capacitor. If the resistance is low, the firing angle, which we are most concerned with in this experiment, as well as the charging time of the capacitor is low, and if the resistance is high, then it will take more time to charge. The triac is a unidirectional device. It consists of 3 pins, namely first MT1, second MT2 and third gate. The gate terminal, that is third pin, is directly short with the diode. As the triac requires triggering pulse to perform its operation, here a diac provides triggering pulse to the triac when the voltage in the diac reaches the breakdown voltage. As soon as the triac is turned on, the voltage across the capacitor decreases rapidly due to zero value. The triac is now turned on with the firing angle. During the positive half cycle of AC signal, the capacitor charges with upper plate positive and lower plate negative. Hence, the firing angle pi minus alpha is what we obtain. The intensity of lamp or the bulb that we have in the experiment will depend upon the value of firing angle of the triac. Less the value of the firing angle alpha of the triac, more will be the voltage across the lamp or the bulb, and hence more will be its intensity of illumination and vice versa. Today I'm performing Diac Triac light dimmer experiment. As you can see, I have a Diac Triac light dimmer circuit board. I have a variable AC supply through which I'm gonna supply 80 volt AC. And in order to protect this circuit, we have the ultra isolation transformer, which is going to make sure that in case of enemy is happening or extra voltage being supplied to the circuit, it separates the circuit from the board, so that the board is safe. So we have connected the ultra isolation transformer, the variable AC voltage supply, and the light dimmer circuit. Now if we concentrate on the board, we can see that by using the knob we have set the voltage supply to 80 volt, and this is directly applied to the input of the board. Here, as you can see, to 60 to 80 volt. The load is directly connected to the CRO, and as we can see, since the switch is turned off right now, therefore we don't see any graphs on the CRO at this point of time. As I switch it on, and now we can see that if as I vary the potentiometer, we can see that the bulb starts glowing depending on how much I rotate the potentiometer and depending on the that is the resistance and the firing angle. And at the same point of time, if I take a look at my CRO, we can see there are graphs out there which depends on how much I rotate the potentiometer, or we can also call it due to which we get the firing angle, as you can see here.